Welcome to another TIBCO BusinessWorks lesson. Today we'll discuss about shared resources which are shared throughout the entire application module. These include connections to databases, HTTP, messaging servers, and much more. In the last lesson, we talked about process variables. Today we'll delve into job shared variables and module shared variables, both integral to shared resources. These two types of variables are very useful in your application's logging process, helping you track input-output requests, responses, and other crucial information. Let's start by creating an XSD file in your schemas folder, naming it logging. Within this file, we'll create a log element designed to hold useful information for logging. As useful fields, we can define the application name, an ID that identifies the execution flow, the current date and time, the name of the process performing the log, the current step whether it's the start or end of the process, and a payload where the actual input and output of the process are inserted. Now let's create a logging package containing the log process. We'll associate the start activity with the schema we just created. A module shared variable is a global variable that any execution flow can read and overwrite. These variables have a life cycle equivalent to that of the application itself, so they usually set in the application's activator. Therefore, in your module descriptor under shared variables, let's create a string-type module shared variable named application name. In this example, we'll simply insert the application's name. In one of the next lessons, we'll see a more practical example of how to use these variables. In the activator process, as seen in our first lesson, we'll insert a set shared variable activity within the onStartup operation. Here, decide whether it's a job or module shared variable, select module, and you'll see all created ones. For us, the only one is application name to which we reference it. In the input, we'll put the string learning. Let's move on to job shared variables. They are also variables visible from the application module, but unlike module shared variables, their life cycle is confined to a single execution flow, meaning from the beginning of a component process and throughout the hierarchy of process calls. Therefore, our job variable must be set for each new execution flow. In our case, we will identify each execution flow using the flow ID element of our log. Still in module descriptors, under shared variables, let's create one string type this time in the job shared variables section and name it flow ID. In the timer process, insert the set shared variable palette. Here instead, select job shared variable and reference the one we just created. In the input, insert the UID function, which returns a unique identifier. In this way, for every component process execution, you would have to insert this palette to obtain a different unique flow ID. If you're finding this information useful, remember to hit that like button and subscribe to the channel so you don't miss out on future content. A smarter approach is to insert it into the newly created log process, cut the palette and paste it into. Every time this process is called, it will set a new flow ID. We can handle this by branching the flow, insert a get shared variable palette and reference it to our flow ID. On the branch that goes into set flow ID, insert the condition where the retrieved variable has a length of 0. Otherwise, branch the flow to an empty palette. So now, if the variable is retrieved, we will use that, otherwise, we will set a new one. Insert another get shared variable that retrieves the application name module shared variable, connecting the empty palette to it so it can retrieve it in any case. Insert a mapper that references the log element. In application, we map our module shared variable. In flow ID, we insert the condition that if set flow ID exists, we take the string from the aforementioned palette, otherwise, we take it from get flow ID. In datetime, we insert the current datetime. For the remaining 3 fields, we'll map the data coming from start. These will be the only fields you need to populate when this process is called, as the others would be overwritten. Insert the log palette with the renderXML function of the newly created mapper. Finally, all that remains is to insert calls to the log at every start and end point of our processes, making sure to map the 3 fields we described: the process name, which is available from a predefined constant, the current step, and the corresponding payload. Once the first one is created, we can copy and paste the palette, but modify the mapping as needed. Do that for all the called subprocesses. Insert even logs with step error, where we log all error details in catch section, and rethrow the error to the parent process. Set the timer to start twice, 5 seconds apart. Launch the debug, flagging the processes it will dynamically call as from the last lesson, and the activator, which is necessary to set the module shared variable. We can see the logs directly from the console. Application is learning for all. The flow ID changes between the first and second execution. Date time is in incremental order. And finally, we can see the process names, steps, and payload. Copy a log to Notepad. As you can see, the nested XML is not formatted. You just need to have the XML Tools plugin installed on Notepad, select the text, and select Uniscape characters. As an exercise, try this. Create another job shared variable to log the flow's start time for each entry. For the module shared variable, add one that links to a schema with operation and symbol fields, like / for div and + for sum. After setting this in the activator, your goal is to replace the operation name with its corresponding symbol. I hope this lesson was helpful. If you liked it, leave a like and subscribe to the channel for future tutorials. Your support helps me create new content. For any questions, feel free to write them in the comments. See you next time.